Right. Good afternoon, students. This is Gangadhar, your mathematics teacher, and we are discussing trigonometry in this classes. Right. See, we already learnt about the values of different trigonometric ratios along with the trigonometric identities and some problems related to these in the previous classes. And now, in today's mathematics session, we are going to solve one more problem, a very useful one and frequently faced situation, that the question is saying that we need to find the quadrant in which theta lies. Have a look at the situation. We need to find the quadrant in which theta lies. If secant theta plus tan theta is equals to minus 2 by 3. If secant theta plus tan theta is equals to minus 2 by 3, then we need to find the range of theta, the quadrant in which theta lies. So, how to solve the problem? Have a look at this. Yeah. Secant theta plus tan theta is given, and to decide the quadrant in which theta lies, I am just thinking about different trigonometric ratios. If I found all the trigonometric ratios, and for sure, what we say, in one quadrant all trigonometric ratios are positive. In second quadrant, sine is positive and sine and cosecant are positive. In third quadrant, tan and cot are positive and all the remaining are negative. Whereas in fourth quadrant, cos and secant are positive and all the remaining are negative. We know it, okay? And now, see, since secant theta plus tan theta is given as minus 2 by 3, from there you just try to find some trigonometric ratios. What I am going to find is sin theta and cos theta, right? If I know the values of sin theta and cos theta, after having the values, I will try to decide the quadrant in which theta lies. So for that, I will start the solution with the known trigonometric identity. See, we have this identity, secant square theta minus tan square theta is equals to 1. Is it right? You know it. Secant square theta minus tan square theta is equals to 1. And that secant square theta minus tan square theta can be written as, this can be written as secant theta plus tan theta into secant theta minus tan theta is equals to 1, right? And now secant theta plus tan theta is minus 2 by 3, and then from this you can find the secant theta minus tan theta. So replace this secant theta plus tan theta with minus 2 by 3, and this is secant theta minus tan theta is equals to 1, and if you send that minus 2 by 3 that side, it will become like secant theta minus tan theta is equals to minus 3 by 2. Is it clear? Yeah. Actually, I have secant theta plus tan theta in the problem, and I found that secant theta minus tan theta as minus 3 by 2. Now you just pay your attention on the two expressions. One I have secant theta plus tan theta, and here I have secant theta minus tan theta. And now I will add these two as well as I will subtract these two to get secant theta and tan theta. Right? Yeah. In one situation, if I add secant theta plus tan theta is as minus 2 by 3 with secant theta minus tan theta is equals to minus 3 by 2, right? And now if you add, what will happen? If I add these two things, tan theta will get cancelled. I left with 2 secant theta is equals to minus 2 by 3 minus 3 by 2, right? And there you can simplify it. The LCM is 6. And then 4 and 3 3 is 9, 13, and you will get secant theta is equals to minus 4 minus 9 minus 13 by 12 is the value of secant theta. Yeah, I have the value of secant theta which is minus 13 by 12. And look there. See, secant theta is minus 13 by 12. Secant theta is negative. Since secant theta is negative, then for sure theta lies in either second quadrant or in third quadrant. Why? Because we know that in first quadrant all the trigonometric ratios are positive. If theta lies in first quadrant, then for sure you will get that secant theta as a positive value. Or if theta lies in fourth quadrant, then for sure you will get that secant theta is again positive. But here secant theta is a negative value, that's why secant theta lies either in second quadrant or in third quadrant. But we need to decide in which quadrant it lies exactly. For that, I am going to subtract that. Actually, I have secant theta plus tan theta is equals to minus 2 by 3 and secant theta minus tan theta is equals to minus 3 by 2. And now, just do subtraction. In the first case, we did addition, whereas in the second case, if you do subtraction, minus plus and it is plus, this secant theta will get cancelled. You have that 2 tan theta is equals to minus 2 by 3 plus 3 by 2. Have a look at there. 3 by 2 is more than 1, 2 by 3 is less than 1, and from there you will get the tan theta as a positive value. That's enough for us actually. We don't need the value, we need whether it is positive or negative, that's it. Okay. With the given data secant theta plus tan theta is minus 2 by 3, I found secant theta and tan theta. At the end, secant theta is a negative value and tan theta is a positive value. Where it happens? See, again I am repeating that in first quadrant all are positive. So since secant theta is negative, theta not lies in first quadrant. Eliminate the first quadrant. Secant theta is negative. In fourth quadrant, we know it secant theta and cos are positive. So since secant theta is negative, eliminate fourth quadrant also. Now you need to think about second and third quadrants. Along with the secant theta, now I have tan theta which is positive. Tan theta is positive only in third quadrant but not in second quadrant. Then from sure it is very clear that by the symbols of secant and tan, secant is negative and tan is positive. That happens only in third quadrant. So theta lies in third quadrant if secant theta plus tan theta is minus 2 by 3. And that's the question. See, sometimes the question may ask you to find the value of sin theta or some cos theta if this secant theta plus tan theta is given. And in some other cases, they may ask you to find the quadrant in which theta lies. So, different types of questions usually we face related to this. Just have a look and I will give you some more. Have a look at this. Look at the problem. Secant theta plus tan theta is given as P and they ask us to find sin theta and cos theta, right? Another similar problem. See, secant square theta minus tan square theta is 1. Secant theta plus tan theta into secant theta minus tan theta is 1. And secant theta plus tan theta you just replace with P. Then secant theta minus tan theta is nothing but 1 by P. Already I mentioned you, if secant theta plus tan theta is equals to P, then secant theta minus tan theta is 1 by P. That in the sense, secant theta plus tan theta and secant theta minus tan theta are reciprocals to one another. One value is the reciprocal of other. If secant theta plus tan theta is P, then you get that secant theta minus tan theta is 1 by P just by this discussion, right? And I think this is very clear for all of you. That's why I am going to erase this. Yeah. In the problem, it is given that secant theta plus tan theta is P. So if you have that secant theta plus tan theta is P, then by the previous discussion, we have secant theta minus tan theta is equals to 1 by P. So at the end I have secant theta plus tan theta as well as secant theta minus tan theta. Now what I do? Right, you just add those two. Add. If you add these two things, what will happen? Tan theta will get cancelled. Secant theta plus secant theta is 2 secant theta and that side it is P plus 1 by P. And if you simplify secant theta, if you took LCM, it becomes like P square plus 1 by 2P. Okay, that was clear. So just by adding secant theta plus tan theta and secant theta minus tan theta, I have that secant theta is P square plus 1 by 2P. And after having that secant theta, I can easily find cos theta. Just cos theta is nothing but the reciprocal of secant, is it right? And cos theta is the reciprocal of secant, and which is nothing but 2P by P square plus 1. Yeah. And I have cos theta also. But what they ask us? They are asking us to find sin theta and cos theta both if secant theta plus tan theta is given. Now, I have cos theta, then how to find sin theta? There are many ways to find sin theta from cos theta. One among them is sin square theta is equals to 1 minus cos square theta. Use this to find sin theta. Yeah, use it. What I have? I have secant theta and its reciprocal as cos theta, which is 2p by p square plus 1. To find sin theta, sin square theta is 1 minus cos square theta. So this is equals to 1 minus square of that cos. See, the cos is this one. What it is? 2p divided by p square plus 1 whole square. That's what we need to simplify. Yeah, how to simplify? Have a look at this. This 2p square is nothing but what? 4p square in the numerator. And in the denominator it is p square plus 1 whole square. I need to take LCM and then I write it like this. P square plus 1 whole square minus 4p square divided by p square plus 1 whole square. Is it right? Both are same. Just think a while. Or otherwise, if you split the second expression, you will get the first one. P square plus 1 whole square by p square plus 1 whole square. This ratio is 1 minus this as 2p by p square plus 1 whole square. Now, look at the numerator. Yeah. How it is there? P square plus 1 whole square minus 4p square. See, if you apply a plus b whole square here, it becomes like p power 4 plus 2p square plus 1 minus 4p square by p square plus 1 whole square. Right. And then pay your attention on the numerator of this. See, 2p square minus 4p square is minus 2p square. That means p power 4 minus 2p square you will get. So this is equals to p power 4 minus 2p square plus 1 by p square plus 1 whole square. And then what you say? Look at the numerator. That p power 4 minus 2p square plus 1 by p square plus 1 whole square is nothing but p square minus 1 whole square by p square plus 1 whole square. At the end I have that sin square theta as p square minus 1 whole square by p square plus 1 whole square. So I will conclude here that sin theta is equals to p square minus 1 by p square plus 1 for this particular problem. Right? In the previous problem, the question is asking us to decide the quadrant in which theta lies. But for this problem, secant theta plus tan theta is given as p and they are asking us to find sin theta and cos theta. So we have an identity that secant square theta minus tan square theta 1. With that, having secant theta plus tan theta is equal to p directly gives us secant theta minus tan theta as 1 by p. So now, if you add these two, you will get secant theta is equals to p square plus 1 by 2p. Reciprocally, you get cos theta. To find sin theta, see we have many ways. Constructing triangle is one of the way, or using this identity is the other way. I am moving with the standard identity. Sin square theta is 1 minus cos square theta. And 1 minus square of the cos, I have cos here, square of that here. And then took LCM, simplify it, you will get that it has p square minus 1 whole square by p square plus 1 whole square. This is sin square theta. But what I need sin theta, right? So remove the square. So sin theta is p square minus 1 by p square plus 1. At the end we have this. Have a look at this. This simplification is completely algebraic part. You need to pay your attention in this simplification. Think a while and I will come with this. I will come with the another idea and another problem. Just have a look for a while. Now look at this. At the end what I have. See, secant theta plus tan theta is equals to p is only given. With proper steps along with the logical identities and the trigonometric identities, at the end we found that sin theta as this p square minus 1 by p plus 1 and cos theta as 2p by p square plus 1. Have a look at this. Yeah. From this secant theta plus tan theta what I found? Sin theta is equals to p square minus 1 by p square plus 1 and cos theta is equals to 2p by p square plus 1. You need to memorize these two as a formula. Okay. And now what I am going to tell you is just you think about the value of p, right? What I am going to tell you, you just think about p. Think about p. Just you separate the value of p maybe in 4 different cases. In first case, the value of p is less than minus 1. In the second case, the value of p is in between minus 1 and 0. In the third case, the value of p is in between 0 and 1. In the fourth case, the value of p is greater than 1. Just look there. What I am going to tell you is, I don't know about p. Okay, p is any number. If secant theta plus tan theta is any number, then I have sin theta and cos theta like that. And now after having sin theta and cos theta, I am thinking about p. If you just think about p, that p has 4 different options. Either p less than minus 1, 0, p less in between minus 1 and 0, p is in between 0 and 1, or p may be greater than 1. In all those cases, I am going to decide the quadrant in which theta lies. What I am going to say? I am going to find the theta in which it lies. Now look there. P less than minus 1. See, p less than minus 1 means p is a number which is less than minus 1. So in those cases, take a number, for suppose take a p which is less than minus 1. For suppose if you take it as minus 2, okay? In this case, one value of p is minus 2. Replace p with minus 2 here, then cos will become negative. If you place p with minus 2, cos will become negative. If you place p with minus 2, sin will become positive. So think that sin is positive, cos is negative. Where it happens? See, I am giving you here the quadrants. In first quadrant, all trigonometric ratios are positive. Specifically, sin theta and cos theta are positive. In second quadrant, sin and cosecant are positive, all the remaining are negative. That's why sin is positive and cos is negative. In third quadrant, sin theta is negative, cos theta is also negative. In fourth quadrant, sin theta is negative, cos theta is positive. Is it clear? Actual discussion is somewhat different with this. In actual discussion, what I told you, I mentioned that in first quadrant all are positive. But here I am just concentrating on sin and cos. So they are also positive. In second quadrant, as I mentioned you, sin theta and cosecant theta are positive and the remaining are negative. But here I need about cos theta, so cos negative, sin positive. Third quadrant, both are negative. Fourth quadrant, sin is negative and cos is positive. Right. Now come to the cases of p. If that value of p is a number which is less than minus 1, if that p is less than minus 1, see, replace p here like minus 2. This is negative and this is positive, right? See, cos is negative and sin is positive. Where it will happen? Cos is negative and sin is positive. It is true in the second quadrant, quadrant 2. This is angle, okay? Theta. And this is what quadrant? If p is in between minus 1 and 0, there are different problems related to this. In level 1, they just ask you sin theta and cos theta. But if you are at level 2 and level 3 type of problems, they ask you to decide theta, where it lies, depending on p. If p is in between minus 1 and 0, that in the sense p is a number which is in between minus 1 and 0. For example, say minus 0.5. See, if p is minus 0.5, this is negative. And minus 0.5 square minus 1, this is also negative. Both will become negative. Then theta lies in third quadrant. If you check here, theta lies in fourth quadrant and here theta lies in first quadrant. Is it clear? Have a look at this. We will face different types of problems. In one type, they ask you just sin and cos in terms of p. In the other case, they ask you to decide the quadrant in which theta lies depending on p. Right? So now, check different reasons for p. P less than minus 1, minus 1 less than p less than 0, 0 less than p less than 1, and p greater than 1. Is it clear? Here second quadrant theta lies, here theta lies in third quadrant, here theta lies in fourth quadrant, here theta lies in first quadrant. So you will face some special type of problems. For suppose, if the p value is given, see, at first in this class we discussed about that p as minus 2 by 3, right? First problem, what we discussed in this class, if secant theta plus tan theta is equals to minus 2 by 3, what will happen? Right? See, I will explain here with for the space concern. If P is equals to minus 2 by 3, what will happen? P is equals to minus 2 by 3. Minus 2 by 3 is a number which lies in between minus 1 and 0. Clearly, is it right? Minus 2 by 3 means minus 0.6 something. So it lies in between minus 1 and 0. So theta lies in third quadrant. That's what we found there. And for suppose if P is equals to some 4, maybe 4 if they gave, where theta lies. If P is equals to 4, then it comes to the fourth case, then theta lies in first quadrant. Have a look at this once again. This is the way to decide the quadrant in which P lies depending on P, where secant theta plus tan theta is equals to P. Right? So, have a look at this.